Well, good afternoon, everyone. So our next session is on taming the toxic Python environment on your laptop. So we have Mr. Dharhas Pothina with us. So Mr. Dharhas has been an individual contributor to Python over a large number of years now, and we are glad to have him at PyData 2023. So without further ado, I welcome Mr. Dharhas and over to you, sir.
Hey folks, so I'm between you and happy hour, so I'll try and make this reasonably interesting, hopefully. Who here has been using Python for a year or two? Okay? Anyone more than 5 years? Anyone not want to admit how many years they've been using it? Okay. Have any of you had to install a Python package? Have you had to work out how to install a Python package? Okay. So my name is Dharhas. I work at QuantSite. We're an open source company. We have a lot of folks who are core contributors of NumPy, SciPy, Pandas, scikit-learn, all that kind of stuff. And we do consulting. And I'm going to date myself. I'm from, my background's aerospace engineering, and I was originally writing things in Fortran and Perl and awk and sed and a lot of MATLAB. And then in 2008, I found Python. And I looked this up. I've been trying to install stuff in Python for a long time. This is the SciPy user mailing list from October 2008. And I'm like, hey, I heard this thing that called Python setup.py install. Is that how you install NumPy? And okay, so I've been here for a while, and even though Python is painful to install now, when I was a kid, you had to walk uphill in the snow both ways and compile everything from source. So it's a lot better, but it still isn't. This comic from XKCD came out 5 years ago. When it first came out, I didn't know whether to cry or laugh. Unfortunately, I still don't know whether to cry or laugh. Should I use Conda? Should I use pip? Should I use poetry? Should I, wait, no, do I double click an installer? Like, no, what's going on? Who has written Python code that runs on their machine, handed it over to their colleague, friend, or someone else, and they're like, nothing works? Yay. Not yay, but yay. I mean, this has been a frustration for me for many years, and now since I actually work at a company that does open source, I've been able to do something about it. What's the problem here? The problem here is we are benefactors of a massive community of libraries. When I started Python in 2008, NumPy was the big thing. Now NumPy is way down here. There's a lot of people I've met who don't even know NumPy exists. They work in pandas or polars or stats models or BioPython or AstroPy or something way at the top, and they don't even know that NumPy is a thing. This is a huge ecosystem, and it's built collaboratively around the world by thousands of people to do cool stuff, and backwards compatibility. It's not even an afterthought, it's not even a thought. Like, I remember back in the day, who remembers Sun Microsystems? They had a thing, you could take a binary from Solaris 1 and plop it into Solaris 12 and it would just work. You go from Pandas 1.5 to 1.53, maybe your stuff will work. 2, no, everything's gone, nothing works. Backwards compatibility is not a thing with Python. And there's reasons for that. The cool new stuff that's coming out is cool and it is amazing, but it's an issue. This is an image I pulled from the internet of a simple library, I don't remember which one, but a simple library that is used and all the different packages and dependencies it depends on. This is complex. The environments we use for doing our work are difficult to create, they're difficult to maintain, and they're extremely difficult to share. Who uses requirements.txts? Who uses environments.yaml? Who uses both? Okay. Neither of them are perfect. They all have problems. You know, this is not a Conda versus pip versus poetry thing. The state of the Python ecosystem for packaging is problematic. There are social reasons for this. There are historical reasons for this. There are really strong technical reasons for this. Python's a glue language that calls other languages. So we don't only have our own packaging problems, we have all the packaging problems of Rust and C++ and everything else we depend on. I don't have it in this slide deck, but if you look at the abstract, I link to a blog post which talks about kind of the deep technical problems and kind of what's the way forward on some of these ecosystem-wide problems. Python is the bane of enterprise IT people. They hate us. We want flexibility. We want the latest version of pandas. We want, oh, polars came in. I want to try polars. I want the next version of, I don't know if you know, PyTorch compile is now a thing. You can take a NumPy code and you can do it at compile and you can run your NumPy code on GPU. That is a feature that came out in the latest version of PyTorch. We want that flexibility. We want to be able to do that. The flip side is reproducibility becomes a problem. Because as we're moving really fast, we install stuff. This is typically what I've seen most people do. Like, I need to use Python, I'm going to download it, I need to use these packages, I'm going to install them. Oh, I want to use the next version of this package. Conda upgrade, pip install minus upgrade, this package. Oh, there's a new thing coming out. Oh, there's a new thing called polars, pip install polars. You agglomerate or aggregate this environment over time that is now this holy thing that if you push it slightly, it will fall over. And you cannot recreate it because you did installations at various points in time and the state of the internet and available packages was different at those times. Even if I have a requirements.txt, even if I have a environment.yaml, conda, if I ran that 6 months ago and I ran that same requirements.txt today, I will get a different set of packages. This is fixed. We have containers, right? Every IT department in the world, we have containers. We fixed this. Who here knows how to write a Docker file? I'm sorry for you. Sorry. Who enjoyed the process of learning how to write a Docker file? Who would be totally fine if they didn't have to know that there was a thing called Docker files? Yeah. Every IT department everywhere is like, just write a Docker file. That's too high of a lift. And the other thing is, what we've seen in, when we consult with a lot of organizations and industries and everyone else is, most organizations, their IT departments or their IT sysdev, their DevOps groups, they're used to something like Oracle. You upgrade Oracle once every 3 years. Maybe if you're really aggressive, maybe you apply a patch every 6 months or a security patch a month. They're not used to data scientists saying, hey, something released on Friday, can I have it? They're like, no, okay, fill out a change order. Let's say, okay, you want a change order, fill out these are the packages, get it signed by a manager, get it signed by your manager's manager, and the manager's manager will put it in the queue. It'll go through our CI/CD system, our verification scan, our security scan, and in about 8 months, it'll be on the production Docker image that you can use, and you're like, okay, I need the next 4 versions now. And so containers aren't the solution. Containers give you reproducibility. They don't give you flexibility. Who's ever started analyzing a new data set or a new thing, and only after starting your project you realize which packages you needed? Yeah. That's the problem with this idea in companies that you can define all the software you need at the beginning of a project. We did one a couple of years ago where we were looking at analyzing traffic data, like how many people turn left at this intersection, stuff like that. And there's a really good pandas extension that lets you do routes and stuff. We didn't know we needed that, but we needed to get it installed quickly and deployed. Most organizations are not able to transition this issue between I want flexibility and I want reproducibility. You pick one or the other. there are best practices. People have been around for a while. You learn what not to do. And this isn't all of them, but these are the core 3, I would say. Always use an environment specification. Never write pip install or conda install on the command line. Never. If you see a colleague doing it, slap them. Have them write a requirements file that lists all the packages they want. They've done that? Great. Not enough. I told you. We had this problem. We were doing a project for a company around recognizing brand images in videos. Like, you see a video, you see the Chase logo, you want to say, oh, the Chase logo is in this video. So we found a good model that was built about 8 months before the project, and they published a requirements.txt. It took us 2 weeks to get a working environment, because in those 8 months, so many of the packages they depended on changed. Even though they pinned some packages, sub-dependencies of those packages change. So after you have an environment specification, you install your environment and you create what's called a lock file. A lock file is the exact list of every single package that was installed because you have that requirements.txt, including the hash and the architecture and all that kind of stuff. Second thing, you have an environment, you suddenly realize, oh, I'm using pandas, but all my data is in Parquet, so I need to install Arrow, or I need to install PyArrow. Do not type pip install PyArrow. Do not type conda install PyArrow. Do not, if you need the next version of pandas, don't say pip upgrade pandas. No, go back, put it in your environment specification, make a new environment. That is the safest way to have environments that can be recreated. Okay, there are more. If you do some of these things, you can have reasonable reproducibility. But doing this consistently, and remembering to do it all the time, it's a lot of extra steps. Now, where are you going to put the log files? Are you going to store them somewhere? Are you going to put them, how are you going to manage all of this? That's what we've been building over the last couple of years. It's a tool we call Conda Store, and we've taken some of the best practices that exist for the Conda ecosystem. We're talking about making it also work with pip, but we'll see. And we're going from, you tell us what you want. We will make sure we follow all the best practices under the hood and give you an environment that's reproducible, that you can transfer to other people, all that kind of stuff. I'm going to go into a live demo in a second, but before that I'll just show you the UI part of it. The UI tries to force you into a best practice. You specifically have to, give it an environment name, duh. Put out your specification, and then it lists what's installed as dependencies. It lists where it's coming from, and it automatically creates a log file, a Docker image, a tar.gz that you can unpack somewhere else. So you're divorcing your specification from the artifact. The artifact is an environment. You might want to run it locally, you might want to run it in the cloud, you might want to ship it to someone else's machine. We want those to be two separate issues. We originally built this for the cloud, for Jupyter Hub and other cloud platforms where you have multiple people. But recently we also got it working for a laptop. And so that's what this talk is. And I'm going to go into a live demo now. Hopefully you'll go back to this XKCD, which is a lot older. We're like, oh, Python's amazing, we can fly. So anyway, I'm going to switch to a live demo, which I probably should have used a different mic, since now I'm going to hold the mic and do this. So first I'm going to go, so this is a cloud-hosted version, because this has some extra features that don't make sense on the desktop. But in the cloud-hosted version, you see I have my personal space here, and these are environments that I own. I can edit them, I can change them, I can do whatever. I can basically say, add a new environment, and I'll walk through this in a second. And then we have down here, other environments. So I gave a talk at PyCon earlier this year. We did a tutorial. And we have this PyCon environment, the PyCon namespace or group. And in this namespace, me and my colleague Pavitra have edit rights. Everyone else who has access to PyCon 2023 group only has read rights. So they can't change anything here. They can just use the environment. And so this is some of the more, how you can use Condor in a corporate setting to have role-based access to environments and editing environments and all that kind of fun stuff. I'm going to switch to a local version. So this is a local version running on my computer. And if you see, I've got a couple of environments. So let's actually create a new environment. Let's just say plus, let's say PyData NYC. Okay, now I need some help. What do we want to install?
Python.
Yeah, okay, that's good. Python, we can do Python. Actually, let's put a version constraint on that. Actually, I'm going to switch to YAML on actually. Okay, so let's do, which version of Python?
11.4.
11.4, okay, let's do 11.4. Actually, let's make it equals, okay? Okay, you know what, I like polars. I went to polars talk earlier, I think they're cool. Okay, so I got polars and pandas. Good? Okay, so now I'm just, actually, you know what, let's actually explicitly say we want this to come from CloudForge. You know, we don't want to use the default style, we want it to come from CloudForge. Now here, in the background, it's making environment.yaml file. Same thing, it's just a nice UI on top of it. But when I hit create, this is kicking off a few things. It's kicking off a service that is going to build the environment, create a bunch of artifacts, create a log file, and I'm going to go back to here, to one of my created environments. If we look at, let me go here, let me look at something I built recently. I built this, I was playing with JupiSQL earlier today. So here, if you look, I now have a Docker image, I have a log file, I have a log file, I have a tar.gz. One of the new features that we have funding for that should come out in the next couple of months is also say build for all platforms. Right now this is building, the cloud version is building for Linux and my local version is building for OS X. We're going to have a checkbox saying I want you to try and build an equivalent environment for Mac, OS X, and Windows. Okay, that's great, nice, I get some environments. Now here's the other thing. Have you ever tried to install something and you had an error and then someone asks you, hey, what was the error? And I'm like, I don't remember, there's like stuff spread, I can't find it now. Okay, so I tried to break environments, and so here, I have fully versioned environments. So I can go back to this one. Let me go back to this one. And here, I did something that I know will break. I said pandas greater than 2 and NumPy less than 1.2. I know that's going to break. And that was just for this. But now, I have the log from that install. So I can show it to someone and say, hey, this broke. But also, I have all my active versions. Actually, let me go to this one. So here, this is my active version. I have scikit-learn, TorchVision, and PyTorch. Is this one? Oh, no, this is not the one I was going to do. I was going to do this one. Okay, so I've got TorchVision, PyTorch, and pandas. But now, I can go back to this one, where I don't have pandas, and I can click Edit, and I can say Change Environment Version. Which one do I want to go to? I want to go to this one, and change it. And now this is my active environment. So I can go back to previous versions of my environment, and there's no resolve. This is the exact environment I used 6 months ago, or 3 months ago, or whatever. So now you have the ability to roll forward and back perfectly without having to try and reinstall from an old YAML file that may not work. Then, and let's see, is there anything else I was going to talk about? Some of the other things we're hoping to do, which this is more down the line, is in the cloud environment, it kind of makes a lot of sense that you have the different groups and stuff like that. But you can also see we now have the base for saying something like publish my environment, or get my environments from my colleagues, or having that kind of feature where you can upload or download pieces. Is there anything else I was going to show? I think that's about it on the live demo. I will say, the desktop version I showed, so we've been using this in production at multiple companies in the cloud, in kind of a data science platform, Jupyter Hub type setting for like 2-3 years now. But the desktop version and Mac compatibility and Windows compatibility is basically bleeding edge. It just got merged a few days ago. And so right now, you can use this on your desktop, but it's not really production ready yet. It works, but please use it. And we should have a release. Right now, you have to pull from main. We should have a release and an installer in the next week or two. But I think my mission here, I've been dealing with packaging and environments for years. It shouldn't be something we have to worry about. We should be able to install stuff. We should be able to share stuff. We shouldn't have to deal with, well, what's on my computer. And so that's the goal that we're pushing with this. This project is now part of the Conda incubator thing. So it's something we built and then we've submitted it, and now so it's on its way to becoming an official part of Conda through the incubator program. And if you want to use it and give feedback, great. If you want to help us develop it, great. We'd love all that. I think with that, I will take questions.
So this is creating Conda environments, so the only thing the other person needs is Anaconda installed on their computer?
No, you don't even need Anaconda.
Don't even need.
Yeah, you can use, so there's a tool that actually, this gets into the weeds. There is the simplest way is there's a tool called MicroMamba, and if you point MicroMamba to one of these log files, it'll just take the log file and recreate the environment on their machine. Or you could give them a link to the Docker file, or if you have Anaconda, you could use Anaconda. So there's like multiple options once you have that log file.
And then what do I have to give them off of my laptop so that they can reproduce it on their laptop?
So ideally, if you want it, okay, so there's a couple of layers there, because are they also on the same, are you Linux in their Windows, or are you Linux and Linux, Windows and Windows? So there's a couple of pieces like that that are still sort of like how we manage that. But ideally, if I show you here, this log file, this log file is a JSON file that exactly specifies every package and its hash and where it came from. And so with that log file, and there's various tools. Conda log has a tool, Mamba has a tool. So there's several tools that can go from this log file to a environment. You could also, if they are on the same platform as you, if they're on if they're on Linux, you could hit this download archive button, and that's a zip file that you can use Conda unpack on, and then Conda unpack in that zip file will give you an environment. And theoretically, we could also push a Singularity image or a Cloud AMI, because again, this is a plugin architecture. We have specification, we have log file, we have artifacts. We have plugins for Docker and a tar.gz file, where you could build your, like if you wanted to build a container for an HPC system, you could build your own plugin to generate that artifact. Other questions?
I feel like one of the things that I often run into, like, at this point when I'm building something and I'm creating the environment, I follow the basic process to some degree and I know what's there. But I'm also often working with old code bases or somebody else who, is just getting started with Python and like who knows what they did on their local machine. And it's like there doesn't seem to be an easy way to sort of like figure out automatically what you need from the code.
No, that's very, very, very difficult.
Right.
That's the problem.
So you still just have to go manually through, look at all the import statements.
There are tools which will help you find all the import statements and pull them out, but that doesn't give you enough, because it says import pandas. Which version of pandas was it? Pandas. And there are some things, okay, because we've done this for a couple of banks, because they have a Docker image that was created by people 5 to 8 years ago who are no longer at the bank, and no one knows where those binaries came from, and we're kind of inspecting them and saying, I think that's not by 1.6, I think, forensics on that is really hard. So it's better to do it up front. And there's a talk one of my colleagues gave at the Packaging Con in Germany, and his talk kind of goes over some of the same things, but from a different aspect. He said, usually by the time you're talking about reproducibility, it's already too late, because you've not thought of it early on when you should have been thinking about it. And so this is trying to, okay, one of the big reasons we built a UI on this, because behind this there's a REST API and there's like a server and all these things. The reason we built the UI is, you know, as you said, if you've been in the community long enough, you know some of the things not to do and some of the things to do. It's very difficult to take that experience and push it to everyone. And one of the reasons we're building the UI is to avoid having to do that. And one very explicit decision we made, like some of the other UIs we've seen, Anaconda Navigator, and there's another one called Gator and stuff, it mixes what you've requested with what's actually being installed. Like if you look at your environments and you do a pip freeze, or if you do a conda list, or a pip list or whatever, what do you get? You get every single package that is installed, but you don't even know what half of them are. One is libc++, d something standard, whatever. That's why we very explicitly, this is what you asked for, this is what you got. You didn't ask for Fortran. But guess what? SciPy uses Fortran. And Pandas uses SciPy. And so we're trying to make it very explicit. You don't need to know about best practices, but we will do it behind the scenes. So that's kind of the approach. Because really, if we want our organization to, you know, use best practices, are you going to go to every single data scientist or engineer and like keep hammering on them on the head with all these things? I don't think you should need to. It is what I'm going for, at least.
So I think you mentioned that conda lock is the main locking mechanism for this spec. So their documentation might.
Oh, and by the way, you can use pip with this as well.
Yeah, of course. Yeah. So their documentation might answer this for me, but just because I'm curious. The most common situation I have in my team is you have one person who writes a library of super interesting things for their niche little part of commercial sales of health insurance or something. And then somebody else is like, oh, I'd love to just install it. So they put it up on GitHub, you can do a pip install HTTPS, you get their package library and stuff like that. Is this able to handle locking things where half of my dependencies are coming from internal GitHub and other half are coming from my conda?
Yes. Okay, so we're still debating how to do this, because so in this, we're trying to work out if we should expose that in the GUI. Currently, if you click on switch to YAML editor, here you can basically say pip and you can put git plus and you can kind of do your thing. We're trying to work out whether we want to expose this to everyone. Because right now it's like, if you're comfortable writing the YAML, you can use that because it's sort of an advanced case. We're trying to work out, one of the big issues when you mix conda and pip, you can mix conda and pip if you follow a few rules. If you use conda to install, digression, the big difference between conda and pip is because pip was built by the web Python community, conda was built by the numerical scientific Python community. I'm glossing over lots of stuff here. Python, most core machine learning numerical Python libraries are a Python library on top of C, C++, Fortran, Rust code. Pip does not know how to handle C++, Rust libraries and dependencies in a non-conflicting way. And there's multiple reasons for that. Conda handles those very well. So if you have two different libraries that both need zlib, a C library called zlib, both those libraries can run it without conflicting. Pip, one of the packages can clobber the other one. So the safest way to do things is install all your core packages, which are numerical, PyTorch and NumPy and Pandas with conda, and then pure Python packages you can install it with pip in the same environment, no problem. If you install PyTorch with conda, and in the pip section, in that same environment, you install TensorFlow, you're likely going to destroy everything because libraries will get overwritten, and we've seen this chaos a lot of times. We are still trying. We have folks at QuantSight who are on the Conda steering committee and part of PyPy and stuff, and we're trying to work out some ways to automatically make Conda and pip work better together. But that's in the future a little bit. And so part of what Conda Store is trying to do is today, pragmatically, what can we do with the ecosystem as is, and then hopefully over time, how do we fix the other issues?
Well, just for clarification, I don't use Conda, but you're saying I can install a dependency within a Conda environment using it?
Yeah.
Okay.
Yeah, that's what this does. Basically, this is the YAML file. Basically, you can put all your Conda packages up here, and you can put pip, and you can put your pip packages down here, and it'll install. And so the other thing pip can't do is it can't install Python. But in Conda, you can actually install different versions of Python. Like Python, you can actually go back to Python 2.7 if you want. Don't recommend it, but you can.
All right, so if I install, more specifically, if I install a dependency within a Conda environment, it'll be a part of the same dependency graph?
Not exactly.
Thought so.
Let me see if I can actually. I think some of these environments. Yeah, right now, unfortunately, all the LLMs. So if you look at this, this is what you can see installed. So a lot of the LLM companies, everyone is doing in ChatGPT or something, they only have pip. They have horrible pip installers that are very easy to break your entire system. But if you look at this environment, I think if I click edit, you'll see. No, this one doesn't have any pip. Okay. One of these has a bunch of pip stuff. I don't remember which one.
Okay.
Yeah.
I can execute Python.
Yes, so here you basically see I've got a bunch of stuff coming from Conda, like Jupyter Lab and stuff, and then these things, AutoGPT, Q and stuff, are only available in pip.
So there's a break and you have to manage that.
Yeah, so the thing is, this will work until it breaks horribly. But at least now it fails reproducibly. You have error messages, you have a log, and when you fix it, you can roll back and forth between the broken and And the other thing, when we use this in the cloud setting, like this, so this environment of this Gen A LLM, one of my colleagues, Dylan, we said, hey, go work out how to install Llama and a few other things. He worked it out. He got it working, and now everyone in QuantSight can use it because it's, we just pick this environment when we want to run that stuff. So part of this is, especially in the cloud environments in Jupyter Hub, if one person works out how to build the environment, now you can share it with everyone else in the organization without having to pass a file between people.
Am I looking at two dependency graphs here? Sorry for the diagnostic question. But
Yes. You are. You are looking at
two
a.
dependency graphs.
We're looking at a Conda dependency graph here, and then we're looking at a pip thing. Now, the danger is, if one of these Conda dependencies installed a core C++ library, pip doesn't know Conda, and pip can overwrite it and break it horribly.
If they're named the same, though, pip will see that installed.
Yes, if they're named the same, pip will see that it's installed and not do it, but for some, there are a couple of packages, like, some of them are fixed. Like in the past, in Conda Store it's called sklearn, and in pip it was called scikit-learn. And so pip wouldn't recognize it was, so that's a whole, let's get some beers and talk for 4 hours on the problems in the Python ecosystem.
But in practice, I mean, I do this all the time.
Yeah.
And I just try to install it with Conda, and like it's not there, and then I go find it in pip, and then it just works.
Yeah, so it just
99%
works.
of the time it just works.
So it just works when you're an individual.
Yeah.
Because half the time most of the Python packages are just pure Python, so it works fine. We're a consulting company who, this is the difference between anecdotes and statistics, I guess. We're a consulting company who works with lots of organizations, and once you're at the scale of I have lots of people trying to do stuff, it breaks all the time. And so any one person, usually like they find something, it works, or one of the hardest things is getting TensorFlow and PyTorch working together in the same environment. I would actually advise, unless you're planning to mix both of them, you have a tendency, like that's why I named this one here. If you look here, I named this machine learning PyTorch, because installing TensorFlow and PyTorch together is very hard, and the number of times I have to use both of them in the same workflow is basically 0. And so just have a PyTorch environment and a TensorFlow environment. Environments are cheap, use them.
Oh yeah, this seems to be pretty informed by like NPM and a lot of the design decisions made there. Like it's funny to see the JavaScript.
It's actually not NPM. One of our developers at QuantSite loves Nix, and he's trying to make all of this work like Nix.
With the lock files and stuff like that. But
Well,
yeah.
the lock files have been around for a while, so it's difficult to say what came from where. NPM has another set of problems where it installs multiple versions of the same package. Yeah.
Well, that's what they're trying to do Dino now, and I mean, it's
Yeah.
one thing after the next. But the one thing that NPM's done pretty well that I start to see pip do is like vulnerability management using like pip audit. Is there any chance that you like want to add vulnerability management to the GUI to help
Yes.
people better understand that?
So I mean, we've talked about this again. If anyone has funding, we would love to accept it, because we have. So the thing is, every environment now has a unique hash, and we know exactly what's in every environment. All we need to do is hit the REST API of a list of CV vulnerabilities, and now we can give you a report for, hey, these are the environments you're running in your organization, and these are what the vulnerabilities are. That would be easy with a little bit of work. Well, easy from the
and more importantly, I think that the challenge for you specifically is making that stuff really human legible, because some people will see extremely benign. Some IT departments will see extremely benign security warnings and do absurd things in reaction.
Go ahead.
So the content, okay, every environment has a unique hash. You mean every environment that's created will be supplying a unique hash, or are you saying that in terms of the content itself?
So we're storing a lot of this metadata in a backend database, and so when this, so actually one of the things which, so how this, this whole active environment, previous version of environments are working is every environment has a unique ID, and then on your desktop we're switching what data science points to, with symlinks, so you can kind of use the latest one or what moved back. But we have a full REST API here, so theoretically, and we've experimented with this. In your Jupyter notebook, if you store the hash, the ID of the environment, or in a script, if you put hashbang, bin, conda store, ID number, we've experimented with it automatically downloading that environment, unpacking it, and running a script in that environment. So once you have a source of truth for your environments, and you can ship them around, there's a lot of things you can do. Okay.
In other words, if I upload this environment, and regardless of metadata, I can name it. I don't care about metadata. If I upload this environment to your system twice, will I receive the same unique identifier?
Okay, so that gets into a different question. Is there a service around this? No, currently this is software you install and use. You can install it for your organization, you can install it personally. What I would love to get to is, I come from a science background. We get to mint DOIs for documents, right? If you have a PDF or like a report, we have a DOI. I would love to build a service that mints a environment identifier that is unique and anyone can look up, and you basically send your code to someone and say, hey, here's the environment identifier, and you can pull. That would be what I'd love to build. Right now, this isn't there yet. This is a technology, a service like that could be built on, but it doesn't exist as a service. We use this internally. We have a cloud data science platform called Navari. That's an open source Jupyter Hub distribution. We use it in that. We use it at several of our clients. For each of them, they now have a unique source for their environments, but that they don't have a way to share that with someone in another organization. We've talked about, if you look at the shared environments, that section, if you look at that shared environment section, here, this bottom section, theoretically that could be environments that exist on someone else's server. And you click download or upload or something. So again, if you think about this systematically, there's a lot of stuff you could do with it. So again, anyone wants to fund us? I'm happy to take money to build this more. So, and we also, Last plug, we are a consulting company. If you are really annoyed about how your organization or your group deals with environments, we're here to help, both on the packaging side and also building systems like this. So, any other questions?
Can you also help get packages added to Conda through feedstocks? Like if there's a package.
Conda Forge, yeah. Conda, I mean,
Like
so
Conda Forge, yeah.
yeah, we do that for multiple companies. We're actually doing some for the NIH where we're getting the biology packages and converting our packages to publish on Conda Forge. And so we actually have, I used to be on the steering committee for Conda Forge, but for Conda, and then I stepped down. But we have steering committee members on both Conda Forge and Conda, and we have several developers in the Conda ecosystem and in the PyPy ecosystem. So yeah, that's one of the consulting services we offer. It's just, hey, here's a list of packages, get them on Conda Forge. And we also teach people how to do that. Like, if you don't want us to actually do it, we'll train you on how to do it.
But someone still has to approve the PR on the Conda Forge side, which can take some amount of time.
Not when they work at your company.
Like, hey, Jaime, can you approve this PR? No, we see. Usually we see if it's going through the regular process efficiently, but if it gets stuck, we have multiple people who are Conda Forge core maintainers, so they can kind of push it and say, hey, let's get this one through the thing. So. Okay, thank you everyone. And I'll be around